Let's start this video off with number 12. Based on the histogram above of the following, which is closest to the average arithmetic mean number of seeds per apple? Remember to find the mean. You just add up all the numbers and divide by how many there are. So I'll do this two different ways. One method you may see for this one is you can literally just write out every single number. So as we go to our number of seeds for 3, there are 2 apples with there are 2 apples that have 3 seeds in them. So I can do 3 and 3. Same thing for 5. So I'll write 5 4 times. 1, 2, 3, 4. Same thing for 6. I'll write it once. Then 7. I'll write it twice. I don't write 8 at all, and then I'll write 9 3 times. What I can do is add up all these. So that would equal, looks like that would be 73. And then divide by how many there are. If I want to, I can count them all up. It also just tells me right here. It'll be 12. And it'll be like 6.08 something. It says what is closest to average, so the average would be 6. So that's one way to actually solve it itself. Another way to solve it, which is pretty similar, except that instead of having to write out every number, you can just kind of write it out in this multiplicative way. So there are there are 2 3s, and then I add the next bunch, which would be 5 4s, so 5 times 4. Same thing for there's just 1 6. There are 2 7s, and there are 3 9s. Again, divide by, if I want to, I can count them all up. 2 plus 4 plus 1 plus 2 plus 3. Again, it tells you right there, 12. And we'll end up getting an answer that is close to approximately 6. An answer choice of C. Now let's look at number 13. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Which of the following categories accounts for approximately 19% of all the survey respondents? So what they want us to do is see from these 4 categories which of those divided by all the survey respondents, which is 310, will give us 19% of the total survey respondents. So if you wanted to, what you could do is see, okay, females take geometry, that is 53. I could do 53 divided by 310, 62 divided by 310, 59 divided by 310, and 44 divided by 310. I could individually do all these and just see which one's closest to 19%, or I could just turn this into an algebraic equation. Again, I don't know how many students. I apologize.
It's okay.
Alright, and so what I'll do now is I don't know how many students there is, but I do know the total is 310. I want to find some value of x such that when I divide it by 310, I'll get 19%, or I'll get 0.19. And now I could just solve for x. So multiply 310 by both sides, and you should end up getting a value of x that is around 58.9. Obviously, there is not a 0.9 of a student, but as we look at this chart, which number is closest to 58.9? It looks like 59, which is males taking geometry, which would give us an answer choice of C. Alright, let's look at number 14 on this test. They give us a table here of lengths of fish in inches. The problem says, the table above lists the lengths to the nearest inch of a random sample of 21 brown bullhead fish. The outlier measurement of 24 inches is an error. So of the mean, median, range of the values listed, which will change the most if the 24-inch measurement is removed from the data? Real quick before we go into the question itself, let's make sure if we know what mean, median, mode, and range is. I'll do a little small example here with this set of 10 points. Just have the void do everything here with this huge set of points here. So let's look at this. The mean. We saw earlier the mean is just the average. So what I would do is I would add up 1 plus 2 plus 3, so on and so forth, all the way up to 9, and divide by how many there is. So in this case, if I was to add up all these numbers here, I would end up getting 54. Then I would do 54 divided by how many there is. It looks like there is 10 points in this set, so 54 divided by 10, which would be 5.4, which would give me a mean of 5.4. And again, I just made these numbers up. They don't have no significance whatsoever. 1 second. No importance whatsoever to the actual question. It's just an example to show you how to do this. I'll do the median last. Mode is just the most. Which number appears the most in your set. And it looks like we have number 4 twice, but number 9 3 times. Therefore, our mode is 9. And range is just your range of your data. What you do is just you take your highest number and you subtract it from your lowest number. So we'll do 9, which is our highest, minus our lowest, which is 1. That reaches 8. And the reason why I want to do the median last is because normally, the median is the middle number of the set. So rearrange your numbers from least to greatest, and just normally you may have learned it as just marking them off. So 1 from the beginning, 1 from last. So keep going like this until you get to the middle number. In this case, we have 2 numbers in the middle. What I would do is just find the average of those two. So 4 plus 6. Oh, I apologize. I would do 4 plus 6 and divide by 2, and that would be 5. If there wasn't 2 numbers, if it was just 4 or just 6, that would be my median. I say all that just because we need to do all that, but now with this huge set of data. So what they want to know, which of these 3 values, the mean, median, and range, will change the most if this 24 is taken out. So how about this? Let's find the mean, median, and range before 24 is taken out, so with all these numbers, and then after that 24 inches is taken out. So the mean, if I was to add up all these and divide by how many there is, I would get a mean of just about 12. Same thing for the median. I would cross out these like one by one, so 24 and 8, 9, so on and so forth, and I would get a median of 1 second. I would get a median of 12, and then I would do to find the range. I would do 24 minus 8, and that'll be 16. But now what we need to do is literally just take out that 24. That 24 does not exist anymore. It's an outlier. And we do the same thing all over again. This time, the mean would end up being 11. The median would actually still be 12. And the range, well, let's see what our range is. Highest number is 16. Lowest number is still 8. So 16 minus 8 is 8. Question is saying, which of them has the biggest difference? Which of them changes the most? Mean goes from 12 to 11, so just by 1. Median actually stays the same. But look at the range. It goes from 16 to 8. It's a drop in 8. In this case, the answer choice would be C. The range would be the data that changes the most if the 24 inches is removed. Let's look at questions 15 and 16 now. So the graph above displays the total cost, C, in dollars, of renting a boat for 8 hours. Question 15 now says, what does the c-intercept represent in the graph? That word c-intercept should kind of bring back a little flashback of Algebra 1 for you. This little thing called y equals mx plus b. And just real quick, b in this case equals b in this case equals the y-intercept, while m equals my slope. The y-intercept is where it literally intercepts the y-axis, or where it crosses. So whenever it says, what does the c-intercept represent in this graph? It's saying the same thing. Where will it cross the c-axis? In this case, it's just this axis here, this vertical axis. Looks like it'll cross it here at 5. What does that mean? That means at time 0 hours, it costs $5. So it's the initial cost of just renting the boat. So when I show up, I better have at least $5 just to get out of the door with my boat. The answer to choice would be A. Now let's solve number 16. So using that same information, which of the following represents the relationship between H and C? So as we look at this graph here, notice that it is a straight line. That should give you a hint that you need to have your good old, let me get a different color, a good old y equals, oh, 1 second, the good old y equals mx plus b. And as you notice, all your answer choices are in that form. This one just doesn't have a b, this one has a slope and a y-intercept, same thing here, and this one just doesn't have a y-intercept. So how do we do that? How do we find our slope? So you can do two things here. You do have a graph, so you can count between the points. Just be very careful. From the past, when I've seen people do this question, they don't notice that this scale is actually different. This one goes up by 1. This one goes up by 0.25. So notice just how big of a gap there is between 1 and here's just 1. So if I was to not notice that, I would get a slope of 3/4 and a y-intercept of 5, and that would give me an answer choice of B. And in this case, the answer choice actually is not B. So how do we find the slope and how do we find the y-intercept? Well, one thing we do know is we already know what the y-intercept is. We know it is just 5. Because, like we said earlier in this last question, the y-intercept is the place where the graph intercepts the y-axis, or it's just the starting initial value. In this case, we know it is at 5, so we know it needs to be y equals something x plus 5. So that should automatically tell us that it's not A or D, and I kind of gave it away by saying it's C because I said it couldn't be B. But let's pretend we didn't know that. Let's pretend we didn't even know the y-intercept. How will we find the equation now? So let's just find the slope the good old-fashioned way. M equals y2 minus y1 over x2 minus x1. You could pick any 2 points here. I'll go ahead and pick, let's see, 211 and let's see 1/8 and 1/8. And again, you can have either one of these two be your x1 or y1 or x2 or y2. Since this value, since 1/8 is smaller, I'll let that be my x1, y1. So that's x1, y1. And I'll let this one here be my x2, y2. So that when I actually do find a slope, I'll take my y2, which is 11. I'll subtract it from my y1, which is 8. And I'll divide that by the same thing for x2 minus x1. 2 minus 1. 11 minus 8 is 3. 2 minus 1 is 1. 3 divided by 1 is 3. Therefore, my slope has to be I apologize, not y. Oh, 1 second. It has to be y m equals 3. That's an m, by the way. So let's say we didn't know our y-intercept. Let's say we knew our slope was 3, but we don't know our y-intercept. What we can now do is plug this into our slope-intercept form. Let me just clear some space real quick. The equation for the, I apologize, it's this point slope form. It's y minus y1 equals m times x minus x1. That should be an x, and that's a minus. What this allows me to do is to find this y equals mx plus b. So let's just do that. Again, I can use any point. I'll just use the point 1,8 just because it is smaller. So 8 is my y value, while my slope is 3. And then x minus x1 would be 1. And now I just simplify and just solve for y. So y minus 8 equals, I will now distribute this 3 to everything inside my parentheses, so 3x. And then 3 times negative 1, and that'll be negative 3. And just solve for y. So add 8 to both sides. Y equals 3x plus 5. Again, I could have saved myself a lot of trouble there. Saved myself a lot of time there if I would notice that 1, let me get the pointer out. 1, the y-intercept must be 5. Therefore, it's not A, it's not D. And 2, my scale is not going up by 1 on this one here. If I would have saw that, I would have saw that it can't be 3/4, and that would have marked out B. If I would have saw that, then that would have given me an answer choice C right off the bat. If not, the next step would have been just to find the slope, and hopefully you would have saw the y-intercept was 5. If not, you can then plug it into this form here, my point slope form.